Okay, this is our Unit 5 FRQ warm-up. Thought I would go over this on a video for those of you who were not in class for it, or who had to leave early, or we didn't get a chance to finish it in class. These are two really great FRQs over our material from Unit 5. The first type of FRQ problem that you might see involving these concepts is that of a table. In this particular question, the height of a tree is given by a strictly increasing twice differentiable function h, with h in feet and t in years. The height is recorded at selected times given in the table above. So, h and t. All we know about h are these 6 different heights at 6 different times. Okay? All we know about h. Before I go much further, let me address this. Strictly increasing, what does that mean? Strictly increasing means always increasing, always going up, alright? Never even flat. The graph of this h would not even get flat anywhere. Strictly increasing means always going up, never the same, and never going down, of course. If it only said increasing and not strictly increasing, then that leaves open the possibility of it being flat at some times. All right, but not this one. This one's always going up. All right, twice differentiable means that the second derivative of h exists. The second derivative is never undefined. So this is a super smooth curve. No cusps, no discontinuities, no vertical tangent lines. Okay, part A. Using correct units, let's explain the meaning of this expression. So of course we see the integral, but what my eye is drawn to is this coefficient out in front. That coefficient out in front of that integral, which has a denominator that is 7 minus 0. We need to recognize this as the average value of a function formula. This is the average value of whatever function is sitting right here, in this case h. This is the average value of h. All we need to do then is to write it in the context of this problem using correct units. So h is the height of the tree. So this is the average height of the tree. So I'm going to write it like this. The integral from 0 to 7 of h of t multiplied by 1 over 7 is, or gives, the average height of the tree. In feet. The average height would be in feet, and we have to give the units. The average height of the tree in feet. And now we need to give the meaning of 0 and 7 here. So this is the average height of the tree in feet from 0 to 7 years. When you read back your sentence, it should make sense. If it does not make sense, you have done something wrong. Okay? Common mistake I see. Kids don't like to just say the average height. They like to say the average rate of change, or the rate of change of the average, or something like that. They like to include the phrase rate of change. Don't do that here. H is not a rate. H is just a height. So this is the average height. Another common mistake I see kids make is they say things like, they don't give the meaning of h, they give the units of h only. They'll say things like the average feet of the tree, or just the average feet. Read that back to yourself. Does that make sense? Does this give the average feet? No, it gives the average height. All right? So make sure that that sentence makes sense to you when you read it back to yourself. Part B. approximate the average height of the tree over the first 5 years. Get a little highlighter up. Using a left Riemann sum and 4 subintervals. Left Riemann sum. I highlighted that 5 because the table goes to 7. We only want to go to 5, so we're going to stop at 5. Okay. So I'm going to rewrite, well, I was copying that average height from 1 to 5. This will be 1 divided by 5 minus 0. I was just going to write that as 1/5, which is fine. Times the integral from 0 to 5 of the h function, of the height function. And we are approximating this expression using a left Riemann sum. So first of all, left Riemann sum, so we're going to use the left h value each time. And we will multiply that by change in t each time. So, the left h value starts at 0. And that change in height, or sorry, change in time is 1. We add to that the next rectangle's area. The next rectangle's area is going to use the 3.1 as the height, and 2 minus 1, or 1, as the change in t. The next rectangle's left height will be 5.4. We're going to multiply that by the change in time, 4 minus 2, which is 2. The next left height is 12.8. Multiplying that by a 1. There are our 4 subintervals. We're not going to go to 7. Okay? Now, are we done? We have the Riemann sum, which approximates this integral, but we have not taken into account that 1/5 that's out in front. So I'm going to multiply this thing by 1/5. The other thing that we could do there is divide by 5. Even if we had a calculator in our hand, I would not simplify this. I would leave it just like that. Part C. Is the approximation in Part B greater than or less than the actual average height over the first 5 years? Give a reason for your answer. Okay, we used a left Riemann sum on a strictly increasing function. So a left Riemann sum, here's our increasing function. A left Riemann sum uses the left side of every rectangle as the height of the rectangle, and each of these rectangles is going to lie below the curve. So our approximation will be less than the actual average height. A left Riemann sum yields an underestimate. It is less than the average height. Since h is strictly increasing. Okay? All right. Next up, approximate h prime of 3. H prime of 3 is approximately. All right. What is approximately h prime of 3? Well, h prime, our table has h in it. We want to approximate h prime. I know h prime is the instant slope of h. We have no idea what the instant rate of change, the instant slope of h is, but we do know the 2 surrounding times. We're going to find the average slope to approximate the instant slope. So I'm going to the closest 2 surrounding times, and I'm going to use those to create the average slope, and that will be our approximation. So I'm using average height and average time on the 2 closest points. So h of 4 minus h of 2 divided by 4 minus 2. And now I'm going to give those values, 12.8 from the table and 5.4 from the table, over 4 minus 2. I'm going to stop there. Okay, what you have to show there is these two expressions. Now we're going to, using correct units, explain the meaning of h prime of 3 in the context of the problem. A derivative is always, always, always a rate of change in a context. Okay, it's the rate of change of h at time 3. So I'm going to say at 3 years. Oops. At 3 years, the rate of change of the height of the tree is h prime of 3. Now what are the units? H prime, remember h prime is going to have units of h over t, because this is dh dt. H is in feet, t is in years, so this will be feet per year. Feet divided by years. Once again, read it, make sure it makes sense. All right, part E, find the integral from 2 to 5 of h prime. Well, the integral of h prime is h, because the derivative of h is h prime. So the antiderivative of h prime is h, and now we apply our boundaries. H of 5 minus h of 2. H of 5 from the table is 14.5. H of 2 from the table, 5.4. That's it. And now we're going to give the meaning of that. What is the meaning of this integral? Well, the meaning of that integral is the change in height from 2 to 5 years. So I'm going to write that as this integral gives or is the change in height of the tree in feet from 2 to 5 years. Okay? Part F. Very common in a table, a data question, for the very last part to go above and beyond the times that were given in the table. Our table only goes to 7. Now we're told, okay, after 7, something is happening. So after time 7, the tree grows at a rate given by this function. dg dt, another way to express dg dt is g prime of t. We don't have to say that, I'm just telling you, those mean the same thing. Alright? G prime of t is the same thing as dg dt. So they're giving us the rate of change of g, of the tree, of the height of the tree, from time 7 to 10 years. Write but don't evaluate an expression containing an integral which gives the height of the tree at time 9 years. So, we know the height of the tree at time 7 years. We know the rate of change of the height of the tree from 7 to 10 years. So we can use that to get the height of the tree at 9 years. H of 7 is 19.3. We're adding to that the change in height from 7 to 9 years. I'm going to write this as g prime of t, dt. That's it. We have written an expression involving an integral that gives the height of the tree at time 9 years. Okay, next up. Next question. I think I'm going to get a different page. My pen bleeds through these. Okay, let me zoom out a hair to get this all on one page. Okay. Alrighty. Number 2. The next type of problem you will see is covering these concepts is a graphing one where I don't give you the equation of a function, I give you the graph of a function. Let f be a continuous function defined on the closed interval -4 to 6. The graph of f, consisting of 4 line segments, is shown on the right. Let g be defined by g of x is equal to this integral, the integral of f. So in these types of questions where they define this function g to be an integral, I know that all of the questions that I'm asked are going to involve g, not f. Okay? So we are going to need, I know we're going to need g prime, so I'm going to find g prime right here. What is g prime? Well, g prime is the derivative of this integral. And when you are taking the derivative of the integral, it's the derivative of an antiderivative. Those kind of cancel each other out. And then we apply our boundaries. X goes in for t, and then we multiply by the derivative of x. But the derivative of x is just 1. So from that we get f of x. Minus, now you go to the bottom boundary, put that in for t. 0 goes into for t, but then we multiply by the derivative of 0. And the derivative of 0 is just 0. So essentially I would have a minus 0 out here. I'm not going to write that. I'm just going to leave it as g prime is f of x. So this graph of f is also the graph of g prime. And from here on out, I'm going to be thinking of this as the graph of g prime. On what open intervals, this is worded really weird, on what open intervals in -4 to 6 is the graph of g concave up? The graph of g concave up. And we need to give a reason for our answer. Well, g is concave up when g double prime is positive. That's what makes g concave up. I don't have the graph of g double prime. I have the graph of g prime. So what do we look for to examine g double prime on the graph of g prime? I need to plug in my computer. Let me plug in my computer really quickly. It's about to go out. Sorry about that. Okay, what do we examine about the graph of g prime? We examine the slope of g prime. The slope of g prime, we want for the slope of g prime to be positive, because the slope of g prime is g double prime. So the slope is positive from x is equal to -4 to x is equal to -2, and from x is equal to 2 to x is equal to 6. So -4 to -2 and 2 to 6. Since the slope of g prime is positive there. We could have, if we wanted to, we could have used f instead of g prime because f is g prime. If you use g prime, you have got to define g prime beforehand. Okay? If you use f, you really don't have to define it. Okay? But it's nice to define it anyway. Sometimes that is awarded a point on the AP exam. All right, on what intervals in -4 to 6 is the graph of g decreasing? Well, g is decreasing when g prime is negative. And I have the graph of g prime. And I can see where g prime is negative. And g prime is negative from 1 to 6. So from 1 to 6, since g prime is negative, there. Okay, now include or exclude the boundaries. Technically, we include the boundaries. Technically. But if you don't include them, you are awarded full credit on an increasing or decreasing problem. Okay? If I do include the boundaries, I may not use the term there. I will say from 1 to 6. Okay? Not including the boundaries. Part C. At what value of x between -4 and 6 does the graph of g have a critical number? Well, g has a critical number when g prime is 0 or g prime is undefined. That's what makes a critical number. G prime is never undefined because g prime is f, and that's the graph right here. It is defined. They even told me that it was defined. So g prime is never undefined, but it is 0. Between -4 and 6, where we're asked to find, it is 0 at x is equal to 1. So critical number is x is equal to 1 since g prime equals 0 there. I could have said f equals 0 there. Okay? State whether each value is the location of a relative min, relative max, or neither. Okay? When x is 1, g prime is changing from positive to negative. Since g prime is changing from positive to negative, g will have a relative maximum. So at x equals 1, g has a relative maximum. Since g prime changes from positive to negative there. You could also say at x equals 1. You could always do that. If you don't like, some kids don't like the term there, you could always just repeat those intervals. Okay? If you don't like the word there, the term there. All right. What is the absolute maximum value of g? Absolute maximum value of g. When I see absolute maximum value, I think candidate's test. So I'm going to set up the candidate's test. X is our independent variable, and we are finding the absolute maximum value of g. So make sure you fill that out. I'm going to begin with my boundaries that they gave me, -4 and 6. And I'm going to include the critical number of g that we found above. It's 1. And now I just need to find my g values. Okay? I have not found any g values yet, so I'm going to start by finding g of -4. G of -4, for g of -4, I go to my definition of g. And I'm putting -4 in place of x. So I'm putting -4 in place of x. I am not putting -4 in place of t. I'm putting -4 in place of x because of that right there. So integral 0 to -4 of f of t dt. My boundaries need to be switched because right now my lower boundary is up here and my upper boundary, my higher number is down here. So I'm going to switch my boundaries by switching the sign of the integral. That's an integration property. And now I have the negative of the integral -4 to 0 of f. And for that, I go to my graph. I want the area from -4 to 0. And from -4 to 0, it's this area right here. It's that area right there. So either count squares or in some other way find the area. Okay, I'm going to count squares. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 whole squares. I see 2 half squares, so that makes 13. So right now I have 13. And then I see these 2 pieces over here. These 2 pieces, if I put them together, I get a 3. So I need to add 13 plus 3, and that's 16. So the area there is 16. So g of -4 is a -16. G of 6, putting 6 in place of x. Now I need the area from 0 to 6. And from 0 to 6, I have this area. Zero to 6. Okay, kind of messed up. I kind of colored outside the lines, but oh well. You get the idea. All right. So what I see first of all is this slim triangle, and there's another slim triangle here, right? It's the exact same shape, but one is above the x-axis and one is below the x-axis. So those two will cancel each other out for the integral. And all I'm left with is this region over here that is below the x-axis, so the integral will be negative, and it'll be 1, 2, 3, 4, 5, 6 wholes, and then 4 halves. So 8. So that integral is -8. And then lastly, g of 1 is the integral 0 to 1 of f of t. And that is the area from 0 to 1 here. That is this piece, just 0 to 1. And that area is, what I see is, it's half of 4. These 4 blocks, the diagonal cuts it in half, so it's half of 4, which is 2. So g of 1 is 2. Which is the highest g value? 2 is the highest g value. What did they want us to give? They wanted us to give the absolute maximum value of g. So they wanted us to give the 2. So the absolute max, therefore, the absolute max value of g is 2. Our justification is the work that we showed. Part E. Let P be the function defined by g of x times f of x. Find P prime of 3. First we're going to find P prime of x, and then we'll plug in 3 for x. How do you find the derivative of this product? We need to use the product rule. Whoever wrote this is asking, does this student know how to find the derivative of a product? The derivative of the first times the second left alone plus the derivative of the second times the first left alone. That's how you find the derivative of a product. Now we're going to put 3 in for x. G prime of 3. G prime is f. So g prime of 3 is f of 3, which is -3. G prime of 3 is -3. times f of 3. Well, f of 3 is also negative 3. Okay, f prime of 3. F prime of 3 is the slope of f at 3. And the slope of f at 3 is up 1 over 1, so 1. G of 3. Well, G of 3, we need to go find using the integral. So I'm going to go off to the side and find G of 3. G of 3 is the integral 0 to 3 of f of t dt. So back to our graph, 0 to 3 would still be this piece, and then it would be this piece here. Yeah? So once again, the slim triangles are going to cancel each other out, and I will be left with this piece, which is 1, 2, 3.5 below the x-axis, so that is a negative 3.5. Save, stop, we're done. Next up we have a little limit. Okay, so this is asking, does the student know how to do a limit? And does the student know what G double prime is, what G prime is, what G is, what X is? Does the student know all of these things? This is a great question because it asks many different things within the question. Okay, G double prime of 3. We know for a limit we begin by putting in this 3, whatever number is here, in for X. If we get 0 over 0, we use L'Hopital's. But until we get 0 over 0, you do not use L'Hopital's. So first we put 3 in for X. So G double prime of 3. Well, G double prime of 3 is the slope of G prime at 3, and the slope of G prime at 3 is 1. So this is going to be 1 minus 3. I am not going to get 0 over 0, so I am not going to use L'Hopital's. 1 minus 3 will not be L'Hopital's. What is G of 3? Well, G of 3 we found in the above part, so that is negative 3.5. What is G prime of 3? G prime of 3 is f of 3, and that is negative 3. Save, stop, we're done. Okay, not every limit is L'Hopital's. Part G, find the average rate of change of G on this interval. The average rate of change. Average rate of change, in my mind, is always delta G over delta X. So delta G over delta X, which is G at 2 minus G at negative 4 divided by 2 minus negative 4. What is G of 2? Well, we have not found G of 2. We need to go off to the side and find G of 2, just like we found G of 3 up here. Integral 0 to 2 of f of t dt. So back to our graph we go. 0 to 2. 0 to 2. Oh, that's those two little triangles that canceled each other out. So this integral is 0. So G of 2 is 0. What is G of negative 4? G of negative 4 we did find. That was negative 16. Divided by 2 minus negative 4. Save, stop. We're done. Okay. Several very good questions to ask regarding a graph given to us and a function given to us as the integral of that function whose graph is provided. Okay, that's it.